Hello, my name is Kristen Rex, and me and Haramrit and Shengtuo, Trungduang, and Rohan Devni developed an affordable solution for pollution monitoring with unmanned aerial vehicles.
So our goal was to design a proof of concept cost-effective pollution monitoring UAV, or also known as an unmanned aerial vehicle. And in this case, a drone. So, why did we choose UAVs? So there's an overall trend across multiple industries of transitioning from human processes to autonomous vehicles. And autonomous vehicles are cost-effective and they expand our sensing abilities that we have as humans.
A UAV carrying pollution monitoring sensors can fly either autonomously or via human control to multiple different waypoints while repeatedly gathering pollution and location data. This data can be sent back to the human controller who can then use the data to predict potential pollution sources and monitor pollution trends. The main problem with UAVs is that the fact that they are very expensive. In general, UAVs are really expensive, but those um, who are able to monitor pollution are generally more expensive, such as these drones. One is $6,500, another is $12,500, another one is $40,000.
So problems with current pollution sensing UAVs. So they cost a lot to repair and operate, and that would not be cost effective for the average consumer or in the industry.
Our
So our goal was to build a drone for about $600.
So we got a controller, a medium accuracy GPS, Arduino sensors, a power board, and we got the frame and a lithium polymer ion battery and a flight controller, and around $100 for flight repair cost, mainly the propellers, and in total this cost around $600. Um, we did not include the Arduino in the calculation, I think.
No, we did $20. Power distribution board.
That's Raspberry Pi. Oh, wait, never mind. Sorry. So our roadmap was to design and build a custom and cost-effective UAV, and then design and build a Arduino-based cost-effective pollution monitoring device, and use UAV to collect data and demonstrate the concept.
So to measure several gases such as nitrogen, carbon dioxide, methane, and natural gases, we have resorted to using Arduino. We are mainly using DF robot sensors for nitrogen oxide and carbon monoxide. Uh, we are using a sensor from ncd.io for methane. The Arduino will store the data gathered by the sensors, and we will create a graph based on the outputs from the sensor. So the future of Arduino sensors. So we will calibrate the sensors, test them in a controlled environment to ensure that they are accurate. We're in the process of doing this currently. And finally, we will test them in the real world and try to find whether or not our readings are accurate and the code works well.
There are several different challenges when we were building it. There's incompatibility of hardware that forces some use more complicated designs. The software tuning needed to be started from scratch, and constant damages to drone chassis, setback timelines, and increased costs. Especially when we were testing the drone, it crashed multiple times.
So the limitations of our design. So we have pretty cheap sensors, so that means they give us a low accuracy of our GPS location and air quality data. The GPS sensor we used is the M8 standard, and so far has consistently had 5 meters of error during testing. And there's a lot of interference from the motors because they're brushless motors, which means that they have electromagnets in them. Um, we also use air quality sensors that can give fluctuating readings in different temperatures and different humidities. So they only give relative measurements, not definitive gas concentrations. Uh, the low accuracy of the data makes data analysis much more difficult and ambiguous.
Some other limitation of our design is the fact that the flight time is extremely short. Our drone is better at, and our drone and its accompanying battery are very small. So far, flight times seem to be around like 10 minutes, and this limits the total amount of airspace that our UAV can go through in one flight. And also, there's no real-time data transmission. Our drone's central flight controller can only handle limited computations. Our drone cannot transmit lots of data through radio. This makes real-time monitoring of our drone's progress difficult. And so far, our radio can handle the GPS, can only handle the transmission of GPS data, drone battery voltage, motor RPM, and internal temperature. Some pros of our drone is the fact that it's pretty cheap and really cost effective, but it makes only short flights and it gives only limited data accuracy, and it's frequently breaking up parts. However, some of the more expensive drones, such as this one, which was $12,500, have longer flights, accurate data collection, reliable hardware, and a stronger chassis, but they are less cost effective. And yeah.
So the work done this far and future goals. So right now we have built a functioning UAV that can achieve stable flight in air, and we've created a pollution monitoring system using our Arduino. For the future, we still need to program a protocol for the UAV, ground control, and pollution sensing monitors to send commands to each other. So wirelessly, because we can't have our computer connected in the air. And then we also need to apply for a UAV license and perform multiple test flights and analyze the drone's performance. If performance is satisfactory, the proof of concept is completed.
I think we're gonna be using an SD card to transmit the data from the sensors, and then when it comes back to the ground, we'll use the SD card to check the readings, which is a lot more cost effective. Thank you.